And
Yes, sir.
Sharon, your project is not valid here because you have taken the same project title, same project. Okay, so therefore you have to decide how you are going to do this. You know that they are taking this project, no? Then why you have selected the same title and same project? Isn't it? Kiran,
Sir, it was Sharon who gave the idea, sir. He
then
said he would
your
do it.
so
He said he
therefore,
would do it, sir. He said he would do the
huh?
project like alone. We would do the project it later, and
Yeah,
they
okay, sir.
they also
Let,
decided and
let us not
told that they would do it.
let us not try to resolve their problem. Let them do their problem. We'll do our job. Okay. Whatever we need to do, we'll do that. Take decision here. Yeah. Next batch, you start your presentation.
Uh, Good afternoon, sir. My name is Vivek, and I'll be presenting the p- PowerPoint. So I hope you can see the
10 minutes
screen.
only, not more than 10 minutes.
Yes, sir. Can you see the screen, sir?
Yes, you proceed.
So yes, sir. And our project is based on piezoelectric generation and storage of electricity, as we did in the earlier semesters. We'll be continuing the same, sir. So we'll be um, explaining in parts, sir. So first thing is energy generation, and I'll be skipping some of the parts, sir, because of the time limit. History of piezoelectric and thing till meaning I'll be skipping, sir.
Yeah.
So yeah, as we know what piezoelectric uh, material is. So piezoelectricity is observed if a stress is applied to a solid like bending, twisting, or squeezing it. Very simple. So the common materials used for piezoelectric are quartz, Rochelle salt, topaz, silk, dentin, and DNA and tandon. So the quartz is the most abundant material in Earth's continental crust. So after feldspar, so we'll be that's the most used material for piezoelectric materials. So how piezoelectric works? Normally, the charges in piezoelectric crystals are exactly balanced. They are not symmetrically arranged. The effects of charges exactly cancel out, leaving no net charge on the crystal faces. More specifically, the electric dipole. So how piezoelectric city works. Now the effect of the charges, their dipole moments no longer cancel out on one another, and net positive
Vivek,
and
Vivek,
so
electricity. Spell it
it's
out. Read it. Tell that again. Pronounce
electricity, electricity.
electricity. Don't say it as electricity.
Yes, I'm just
Please
yes, sir.
pronounce it as electricity. Hmm?
Yes, sir, electricity.
Hmm.
Sorry, sir.
No problem. Go ahead. Go ahead.
So yeah, now the effect of the charges, their dipole moments no longer cancel on one another out, and net positive and negative changes appear on the crystal faces. By squeezing the crystals, you have produced the voltage across its opposite faces, and that's piezoelectricity. If you squeeze the crystals, the forces charges out the balances, as you can see from the diagram presented. So this is the circuit diagram of our model, sir. There's a piezoelectric crystal system connected to a rectifier and a voltage sensing switch and a battery attached to it with a storage capacitor to store the electricity. So from as an alternative, as we know that electricity is very much needed for
Yeah, I
I
want Mastan to continue.
okay, so Mastan.
Yes, sir. So, can you play the video, Vivek?
Yeah, I'll just play the video.
Yeah, let me just play the video. Like, you cut the sound, I'll explain.
Okay,
Vivek,
I'll
you
just
can mute it, I'll explain it with the sound.
okay, I just
Yeah. So this is like a general model of the piezoelectric plates all placed together in series, sir. So, one second, sir. So, this one is, there's a full circuit. We make two models, sir. One is the full circuit and one is just for the AC current. like see, sir, this is the LED strip. So like when I press the piezoelectric material, like the light blinks. So this is just to show that there is electricity generated through the piezoelectric plate when pressure is applied. So just by applying pressure, we can see that the light is coming. So that is how the electricity is generated through this. And the full circuit is I'll be showing in the video. So this is just a mat, so nothing, no batteries, nothing, just the electric material, and that's how the electricity is generated. Just a singular mat.
Shall I go on to the next video?
Wait, it will come. Oh, that's the next video. Is it okay? Yeah, go to the next video. So in the first video, it was shown that there is voltage producer, but it's AC voltage. So we need to convert that AC voltage into DC voltage so that we can actually use it on daily basis, because it's a varying voltage and we can't store it. So that's why the other model. So this is the other model, sir. So this is like, we had soldered it. We couldn't do it perfectly, sir, because like couldn't solve it perfectly. But like when we do the proper model, it's just a prototype. So when we do the proper model, we'll do it properly. So in this AC voltage, sir, so it won't stay, sir. The light won't stay for long.
Yeah, show the full project at once. Full product once.
1 second.
Just hold on there.
Sir, here, sir.
Pause it, dude.
1 second. Full. 1 second. Yeah, go ahead now.
Yeah. Yeah, where's the second part?
I think this is the second video, right?
In the second video, I've shown the other circuit, right?
Oh, just a minute.
Yeah. Let's move forward. Yeah, this one. Wait. So in this, the full circuit is made, sir. This one is properly converted from AC to DC voltage in this one. In the second circuit. So like we used like a transformer to like make it into a constant AC voltage, like to make it like 12 volt or a 6 volt transformer. Then from that, this is like a 12 volt transformer. So it's a step down transformer. So we will be getting 12 volts, and from that we have connected it to a diode, to a full wave bridge rectifier made from 4 diodes. We only made that rectifier. We used soldering and we made it. 1 second. Skip bro, little bit.
Rectifier, so that's
yeah. This one is the full wave bridge rectifier. So this one.
We made it.
Pause it, bro. Pause it there. So like
Just
this is the full wave bridge rectifier. We have used 4 diodes.
Hold on. Yeah, go ahead.
This is like the full wave bridge rectifier. We use this. This is what converts the AC voltage into the DC voltage, and then we use the capacitor. And from that we can like we actually need a multimeter, sir, in this to show the proper generation, because if we make the proper model, we actually need to like fully cover it and then make it like a mat. So in this we could not make the proper model because we could not get all the elements. We did as much as we could. So in this, if we didn't get a multimeter, but if we could get a multimeter and we can connect it to that, and then if someone steps on this one or they tap it with their hand, you can see that there's a voltage generated.
Sanjay Gowda, continue.
Yes, sir. So I'll speak with the specification and profit, sir.
Whatever.
Specifications are.
Sure. Just a minute, sir. We also have some of the applications, so I'll just brush it up, sir. Narendra will do that.
Yeah, Narendra will do. Okay.
Yes.
Share PPT. The power generation sidewalk. If anyone walks on the mat, there will be a producing of electricity.
Yeah, that's okay. That is done. Yeah, shown now with the video.
Okay.
So pressing on, put on that mat will produce electricity. Okay.
Okay. The applications is we can implement in gyms and workplaces in mobile keypad and keyboards like there was in past BlackBerry and Nokia phone with this type of model. In down that we'll place a piezoelectric material. If you press on the buttons, there will be producing electricity. So there is no charge. There is no you can't produce electricity by pressing buttons only. So there will be a producing of small electricity, so you can charge the phone. And in power generation shoes, by implementing downside of the shoes. Continue PPT. You can place on the floor mats and in powered dance clubs. Next. In smart highways. Next. No, next. I think it's same.
Sir, it is
Yeah.
also being implemented in Israel.
Okay.
So like Sanjay, you can continue from here. I think.
Okay, fine. Next batch, I think that's done. Model is shown. Okay. Next batch will take up.
Yes,
Right.
sir. Thank you,
Next.
sir.
Okay.
Abhishek H. Chaitanya. Abhishek.
Sir, we can leave the video, right? We can leave the.
Yeah.
Okay, sir.
Abhishek, Chaitanya, Mahesh, Ramesh, Shashank.
Yes, sir.
Who are all there?
Yes, sir.
Shashank is there. Okay. Then Chaitanya Patel, okay, is there. Mahesh Madiwal, I think you will not come, no? Abhishek H. Who is this Abhishek H. Chaitanya?
Sir, he's a regular student, sir.
Abhishek Harinarayan, oh, that fellow. Mahesh, Ramesh is there. Ramesh is?
I'm present, sir.
Right. Only Mahesh is missing, no? Chaitanya?
Yes, sir. Only Mahesh is missing.
Okay. Start your presentation,
I'll-
not more than 15 minutes.
Yes, sir. I'll present it now. I'll present our PPT. Is it visible?
Not yet. Now it has started.
Okay.
Hey, have you done
our
physical? Wait, have you done physical model?
No, sir. We have done SolidWorks model and simulation on ANSYS.
SolidWorks, so only 3D model, SolidWorks model, and
Yes. Simulation on ANSYS.
simulation.
On ANSYS software, analytical systems. Hello, am I audible?
What is this? You have put a regenerative braking and title is different here.
No, sir. Actually, what happened in the beginning, we had locked regenerative braking systems, but then later we all felt we can work better on this one, and we made the change in the last PBL. But it was not reflected.
Start your work.
Okay. Firstly, I would like to say what is structural analysis. Structural analysis is the determination of the effects of loads on physical structures and their components. Structures subject to this type of analysis.
ಟೈಟಲ್ ಬೇರೆ ಇದೆಯಲ್ಲ
ಹೌದೌದು ಅದೇ ಹೇಳಿದ್ದು ಸರ್ ಅದೇ ಹೇಳಿದ್ದು ಆಯ್ತು ಹೇಳಿದ್ದು ಓಕೆನಾ
Structures subjected to this type of analysis include all that must withstand loads such as buildings, bridges, and aircrafts. There is importance of this project is that the results of this analysis is used to verify a structure's fitness for use. Often it is done before the physical tests. So structural analysis is a key part of engineering design. There are three approaches to this analysis: the strength of materials or mechanic of materials approach, the elastic theory approach, and the finite elements approach. We are using the finite elements approach, which comes under analytical systems. Thermal analysis, again, what it is it's a branch of material science where properties of materials are studied as they change with temperature. Now, as we are doing it on brake disc, the brake disc is usually made up of cast iron, but in many cases it's made up of composites such as reinforced carbon or ceramic metal composites. The materials that we have done our testing on is aluminum, and the other most commonly used for testing is gray cast iron and steel. And then next, coming back to the disc rotor, there are two types of disc rotor. The first type is drilled disc rotor. So as the name implies, drilled disc rotors have holes drilled through the entire disc. The rest is, I think, viewable right here. The second type is a cross-drilled disc brake rotor. The only difference between the first type and the second type is that in the first type, the holes are drilled normal to the disc surface, while in the latter, it is drilled at a particular angle, which is determined during the production stages. The advantage of cross-drilled is that it has a better heat dissipation than the other one. Now, coming to calipers, I would like to call upon my teammate Ramesh to present it.
Good afternoon to one and all. I am now explaining about caliper. Basically, disc brakes are used in many modern vehicles and it is also often used in motorsports. First, we want to explain a disc brake with a ventilated brake disc. And the important components of a disc brake is the brake disc. The brake disc is divided into two parts and have a small holes for better cooling and the other components as caliper. Here a monoblock caliper is shown. The caliper has caliper piston on both sides. Caliper pistons are made up of brake cast iron steel, aluminum alloy, and or plastic. A brake pads are located on both sides.
Mr. Ramesh, is it made out
Hello.
of plastic also?
What, sir?
Is it made out of plastic also?
It's a cast iron, steel, aluminum alloy, or rather than plastic, sir. Caliper, only caliper.
Caliper is made out of plastic.
Yes, sir.
Hey, excellent.
rare
Where is
cases,
it
sir.
there? Show me.
In rare case, sir.
Rare case. Adengappa.
Hello.
ಎಲ್ಲಿದೆ ಪ್ಲಾಸ್ಟಿಕ್ ಅಂತ
ಅದ್ರಲ್ಲ ಸರ್ ಸರ್ಚ್ ಮಾಡಿದಾಗ ಇದ್ರಲ್ಲಿ ಹಾಕಿಲ್ಲ ನಾನ್ ಸರ್ಚ್ ಮಾಡ್ಬಿಟ್ಟು ನೋಡಿ ಸರ್
ಪ್ಲಾಸ್ಟಿಕ್
ಹಲೋ
go to next slide go to next slide
what sir
start
and there are two types of calipers sir caliper brakes first one is floating caliper and another one is fixed caliper brakes and
next
floating caliper disc brakes are they are used in many vehicles sir. These are also called as sliding caliper brakes because the caliper can slide axially. The floating caliper brake, which is composed of caliper with a caliper hydraulic connection through which the brake is applied with brake fluid. The caliper is attached to the brake carrier. The brake carrier is rigidly connected to the another component of vehicle. The caliper is other side can slide back.
Go to next slide.
Guide pins. Hello.
Yes, sir. From this onwards,
so next one will
the screen.
Okay.
From this onwards, Chaitanya will take, sir.
Oh, yalla take it.
Presentation.
Chaitanya.
Yes, sir.
Yeah, Chaitanya.
Yes.
Which slide do you want?
No, you close the presentation. I will present it.
Okay.
Sir, is this visible, sir?
Yeah, it is starting now.
Okay, sir. So from this onwards, I will start from thermal analysis of disc brake rotor, sir. Thermal analysis it is done to analyze the thermal properties. The main purpose of this study is to analyze the thermomechanical behavior of dry contact.
Next slide.
Okay, sir. Next slide. Sir, we have done modeling also, sir. Can I show it, sir?
Yeah. You tell me what software you used and what dimensions you have taken.
This software I have used in ANSI software, sir, which is 2020 R1. And this is the model what we have used.
Modeling is done in SolidWorks.
SolidWorks. Okay.
Yes, sir.
Where did you get the dimensions for this?
In Google we have searched, sir. I have got the dimensions. So we have done modeling.
Okay.
After that, we have imported it to the ANSI software, sir.
Okay.
I'll show in that also. Wait a minute.
Go there. Yeah.
Sir, this is the modeling where we have done two types. First one is the ventilated disc brake and solid disc brake, sir. After
Good.
that, before importing, we need to do meshing, sir. After this is the mesh what we have done, which is done by 3D. But we should also apply the boundary conditions also, sir. What we have taken boundary conditions is the pressure which I have taken is 1 megapascals, and angular velocity is 50 radians per second. And this material which we have taken is aluminum 3003, sir. Okay. This is for the ventilated body, sir. You can see here meshes which are compact and finite elements. And next I will. This is for solid display, sir. One second, I will show this also.
Hey, Chaitanya.
Yes, sir.
Show me the solid model and ventilated disk. You show me which is solid, which is ventilated.
Sir, this is the ventilated display, sir. Because you have it can be seen holes here, sir.
Where not those holes, I say. Chaitanya, you have gap between these two. Now rotate that model. I'll tell you. Rotate it. Rotate it. Can you see the gap between two plates over there? Can you see the gap there, man? That's why it is not here. Not here, I say. Not just drill holes. In between, you have no. You have plate-like thing in between.
This one, sir. Yeah, it's a fin, sir.
It is fins, sir. So when you have fins, it is called ventilated disc. Go ahead.
After that, we have done solid display, sir. I will show that also once again.
It's okay. You go to analysis.
Sir, okay, sir. Sir, what we have used the software is student version, sir, because in this student version we can't do that ANSYS. So if it was a paid version, means we can complete it better.
No, you tell me what you have done. I say, go on. Tell me what you have done.
1 minute, sir. It has been struck. Oh shit. Sir, this is the analysis of this picture we have downloaded from net, sir. Because
then you said structural and thermal analysis both you have done. You have not done anything there.
No,
you
sir.
Just downloaded the material.
Yes, sir. But we have done till the meshing, sir. Because analyzing it was not supported to the software. Because it was a free student version and there were finite elements for more, sir.
What is the literature that you have done? Literature, any literature have you gone through?
No, sir. This concept was taught by my cousin, sir. This how to do ANSYS. So,
what about Shashank? What is your contribution for the work?
His contribution is from analyzing ventilated bodies, sir.
Wait. Let the Shashank tell because he has not presented.
Sir.
Shashank.
Sir, I'm going to continue the next slides onwards, sir.
What continue? There is nothing you have done. You have downloaded the figures from Google. Not that you have done anything. Tell me what is your contribution other than presentation?
And it's a paid.
You are not audible.
The software was not supporting, sir. Hello. Am I audible? Hello.
Abhishek, what is your contribution for the work here?
Sir, me and Chaitanya, we together on ANSYS, we came up to meshing, sir. After that, we couldn't do what we wanted to.
But Ramesh, Shashank, no contribution.
The reason for that is ANSYS paid software is 5,000 rupees per month, sir. We couldn't buy the software. In the free software version, this is only all that we could do, sir.
But this is not enough. Not enough. Just modeling a disk is the total work. Okay. And have you gone through any literature or any work that others have done?
Yes, sir.
What?
We have referred YouTube and Google for reference to this project.
When I say literature means somebody's produced journal papers have you gone through, not Google.
Yeah, on Google only I have gone through that, sir.
How many papers have you referred?
We might have referred some 3 or 4 papers, sir.
Chaitanya, what did you do?
I have learned from my cousin, sir, this model, how to do ANSYS. That's it. I didn't refer any sheets, but I have downloaded for pictures about
But you should do
counting.
something substantial. No, just one modeling will not be enough for you to
But
get marks out of 5.
yes, sir.
Okay.
But
Anyway.
you have from ANSYS, sir.
Okay, fine. Next batch. Nimmala Vagmesh Purushottam Reddy.
Yeah, yes, sir.
One second.
Okay, you can start now. Nimala Vagmesh.
Yeah, okay. Sir, Govind Raj is not there, sir.
No, whoever is there.
Govind Raj M.
Sir, Govind Raj, he is in quarantine, sir.
Oh, is it? Why? What happened? He went out, huh?
Yes, sir.
Jayant Reddy.
Sir.
You are there. Guda Jayant Reddy, Guda Purushottam Reddy.
Yes,
Abhishek
sir.
GL is there.
Yes, sir.
What Abhishek GL? Your internet will not work for class. For this, it's working.
No, sir, I am starting only.
Okay. Nimmala Vagmesh, you are there?
Yes, sir.
Okay, start your work. Present your work. Quick.
Okay, sir. Okay.
Again, mobile.
Sir, laptop is not there.
What is the title?
Sir, our project title is quick lifting jack using dual bus.
But you are given your design fabrication of hydraulic jack. Have you done model?
No, sir. No, sir. We didn't done the model, sir, because here we didn't get that certain equipment to that.
Lifting jack using dual gears. Is that the title?
Yeah, yes, sir.
Have you done any physical model?
No, sir. We didn't done that physical model, sir.
Then what you have done?
Because we didn't get that certain equipment in our regional area.
So what you have done, man, now for presentation?
We just prepared that PPT and some video, sir.
Only PPT, on lifting jack using dual gears.
Yeah, yes, sir.
Yeah, make it fast now.
Our project title is sir, lifting the PBL gas. We reach some automobile garage and they face some problems to lifting vehicles using normal screw jacks too. And our project is focused on the difficulties on difficulty levels of.
Jayant Reddy, have you done any literature review? Have you studied others' work?
Yeah, yes, sir.
How many papers have you referred?
Almost 5.
Okay. Go ahead.
Yeah, we focus on the difficulty level of screw jacks because they are facing some difficulties to lift the vehicles whenever they get repaired. We prepared some by arranging gears. We can easily lift the vehicles to without any impact force by lifting.
What is that background noise, Guda Jayant Reddy?
Sir?
Some noise is coming from the background. Come out of that place. Are you staying in Godown?
No, sir. I'm in outside, sir.
That's what. Are you in rice mill or what?
No, sir. I am in just saying, staying in outside, sir, because of signal, sir.
Go to a place where there is no noise. Yeah, start.
Next, Wagmesh.
Good afternoon, sir. Sir, is it audible, sir?
Start. Go ahead.
Sir. Yes, sir. I'm telling introduction, sir. It will be with the gear arrangement for the automobile
What
garage.
that fellow said, Jayant Reddy.
Sir?
You are telling introduction. What that fellow said then?
Abstraction, sir. The above one, sir.
Abstraction.
I'm telling.
What? No, start. Yeah, go ahead, man.
Yes, sir. It has been developed by the needs of small and medium of the automobile gear with the small skilled labors, and the labor cost also will be less.
Of what?
Sir, wheel gear, sir.
What is your project and what is the labor cost you are talking about?
Sir, this project only, sir, lifting jack.
What lifting, yes?
Sir, lifting jack, sir.
Go to your work. What you have done?
Yes, sir, telling, sir.
Tell main components.
Yeah, okay, sir. So the main components are frame, bevel gears, handle, lifting rod, and the bearing, sir. Yes, sir.
Next.
And in all, yes, sir. And in all the garages, the vehicles are lifted by the screw jack, sir. For this process, we need, for the above process, we need the high manpower, and we should be used by the skilled laborers. For overcoming all the disadvantages of the above, we have to use hydraulic jack, and this hydraulic jack is used to lift the vehicle very smoothly without any impact force. And this operation is very simple, that any unskilled labor can also know the process easily without knowing it, just demonstrating the working of the motorized hydraulic jacks. Hello.
Go ahead.
Yes, sir. Next, our batchmates will continue, sir.
Okay.
Okay, sir.
Which batchmate? Then who will read next?
Batchmate, hello.
Who is reading next?
Sir, Abhishek Jail will read, sir. Componential tools and extensions.
Abhishek Jail, read.
Sir, is it over or still is there? Sir?
Yeah, where is Abhishek GL? Where's Tell? Tell me. Tell PPT. Hey, Purushottam Reddy, where is your friend Abhishek?
I think he left, sir.
He left. Nimmala Vagmesh is there, huh?
Yeah, yes, sir.
Yes, sir.
Nimmala Vagmesh, read, no?
Yeah, yes, sir. The computational tools, yes, sir. We have used the software CAD, computer design CAD, sir, for the allowance of, sir.
Go ahead.
It allows the development of three-dimensional design from which the computational, conventional two-dimensional orthofigure views with automobile measurement can be produced. And this CAD software package is used for the project and SolidWorks, which allows the
what are these
rapid and accurate.
components that you are showing here in PPT? What these components are?
Sir, what, sir? What?
You are showing some components, no? Here. What are those components?
Components of screw jacks, lifting jacks. Sir.
What are those components? Read.
Yes, power screw and bevel gear, crank handle, bearings, jack form, bracket, stand, bolt and nut, sir.
Go to next.
Yes, sir. Sir, working principle will tell Purushottam Reddy, sir.
Yeah, you only tell, man. How many he will tell?
Yes, sir. Yes, sir. Working principle, sir.
You only tell.
Sir, the lifting jack is used for the lifting the heavy load, sir, by the application of smaller force, and the figure shown is known as the quick lifting jack. Yes, sir.
Next.
Sir, we should consider yes, sir. We should consider two bevel gear arrangements, sir. Quick lifting jack and much other technological advancements such as automobile grade and dental chair work, sir. Dental chair work, sir. Dental chair work, sir.
Oh, dental chair. Okay.
Yeah, yes, sir. Dental chair work, sir.
Very good.
And the handle is used to rotate the bevel gear arrangement, sir.
Okay.
Yes, sir.
Okay.
And it can be used as a clockwise and anti-clockwise direction, sir. And we can move, rotate upward and backward direction, sir.
Upward and backward.
No, sir. Downward and upward and downward. Okay, sir. Sorry.
Forward or backward, upward or downward. Okay.
No, sir. Upward. Okay, sir.
Next. Finished?
Yeah, yes, sir.
Okay. Go. Next batch. Nitin, yes.
Nitin, yes. Nikhil. Prajwal V. Rishi Dineshwar. Mazin Omar.
Nitin, yes, is there?
Hello, Nitin, yes. Nikhil. Prajwal V.
Rishi Dineshwar.
Mazin Omar.
Nobody is there already?
ಯಾರಿಲ್ಲ ಅನ್ಸತ್ತೀನಿ 5 ಜನರಲ್ಲಿ.
Okay, we'll go to next. Sanjay N. Sandeep.
Rakshit.
Sanjay.
Yes, sir.
Sanjay, you're there?
Yes, sir.
Teammates. Sanjay, Sandeep.
Yes, sir. Sanjay and
Sanjay is there. Sandeep. Illa. Rakshit is there.
Yes, sir.
Srinidhi. Illa. Satish Shankar.
Sir, Sandeep is there. Sandeep is there, sir.
Satish.
Sandeep is there, sir. Satish is also is there.
Sandeep is there. Where Sandeep?
Yes, sir.
Sandeep is there, I say. Sandeep, Satish, Rakshit is there.
Yes, sir.
Sanjay is there. Srinidhi is not there, and Satish Shankar Gummani, there may be some
Yes,
issue.
sir. No, sir.
He's also.
No, sir.
Yeah. Start presenting.
Yes, sir.
Srinidhi is not there.
Yes, sir.
Yeah, go on.
Yeah. Sandeep, present.
Start, man.
Sandeep, present the screen. Just a minute, sir. Yes. So, yes, sir. Our project-based learning is about Geneva.
What is the title?
Yes, sir. Title will come in the next slide, sir. Yeah.
Hey, what
This is,
nonsense. But you should have title, they say. Yeah, go to title.
Yeah,
Mini using Geneva mechanism.
Yes,
Have you
sir.
done physical model, Sanjay?
Yes, sir.
Physical model have you done?
No, sir. No.
No physical model.
No, sir.
Then what you have done?
All members of the group are in different locations, sir. So
And I'm not asking reason. What you have done in your work right now?
yes, sir. We have studied all the aspects of this Geneva wheel mechanism, and we have done the calculation things, and we did a study on applications also, sir.
Okay, go ahead now. Make it fast.
Introduction. Good afternoon, everyone, sir.
Yeah.
Sunny. Introduction. Geneva drive is a gear mechanism that converts a continuous rotation into a intermediate rotatory motion. The rotating drive wheel has a small rod that reaches into a slot of wheel, advancing it by one step. Sandeep. The Geneva mechanism is a system to convert continuous
Rakshit,
circular motion.
Rakshit,
Sir?
presentation is
Sir?
not reading a textbook.
Yes, sir.
Go ahead.
Circular motion, fixed step circular motion. Geneva mechanism required a rising circular connecting, extending above the rotating disc to lock the slot
Tell me
in
rotating,
the Geneva
tell
wheel and
rotating.
drive it.
Sir, 1 minute.
Hey,
Rakshit.
Rakshit, rotating, you tell.
Sir?
Rotating, you say pronounce?
Sir?
Pronounce.
Rotating.
Huh?
Rotating.
Rotating. What is that, connecting or connector?
Rotate.
What is that is typed there? Geneva mechanism.
Connector.
Read that sentence properly.
Connector.
Read that sentence properly.
Geneva mechanism requires a rising circular connector extending above the rotating disc to lock between slots in the Geneva wheel and drive it. As the wheel rotates,
Where is
the
Geneva
belt
wheel?
also rotates.
Rakshit, where is Geneva wheel? Show me.
Rakshit.
Geneva wheel.
Can't you explain with the diagram?
Sandeep.
Where is the diagram?
Sir, it's in the last page.
That's better. No, first
why
you
you
have
have put
kept
it
it
last
there.
there?
No? You would have kept there itself, right? So that we can explain.
Next, go ahead. Complete your presentation.
Main parts required are Geneva wheel, sprocket, rolling chain, coil spring, shaft, frame and base. So working will be explained by Sanjay, sir.
Why you don't know, Rakshit? You don't know?
Sir, no,
Rakshit.
no, sir.
You
Rakshit,
don't
you
know?
show at least the Geneva wheel where it is.
Sir, belt is there, no, sir. That motor. Motor in front.
So I'll be explaining working. I'm Sanjay. Sandeep, 2 slides back. Yeah. This is the working and calculations. Let's see the working and calculations of Geneva wheel mechanism. Yeah. Slides are not visible. Yeah. So basically, as explained, working will be. Am I audible?
You go on, Mister.
Yes, sir. So as Rakshit said in introduction, it's a mechanism which converts a continuous rotation movement into intermittent rotary motion. Like usually, this mechanism is basically used to automate the mechanism of manufacturing products from one point, like moving the products while filling things or etc. from one point to other point. So in this mechanism, two rotating wheels will be there. One is connected to the motor, which is having a small slot in that. So that is that in a small pin that is connected to the slot. You can see the slot here in a bigger wheel that is called a Geneva wheel that is having slots, and the motor connected motor will having the crank radius of D, and that will be connected to that will be having a pin. That pin is inserted in the slot. So whenever the wheel moves, the pin pushes the main wheel, that is Geneva wheel, from Geneva wheel to to certain position of certain angle of rotation. That pin moves as the motor runs. That pin pushes the Geneva wheel to certain angle of rotation. So as the rotation completes of motor, second again one more slot will be the pin will be introduced to second slot, that again pushes the certain angle. So this process goes on as as the time delay required in a manufacturing process. So that will be introduced in this mechanism. So this is the very useful mechanism in giving a time delay for filling things or packing or etc. So you can see we can see here the calculation part. N is the number of slots in the drive, and A is the crank radius, which is connect the disc connected, or the wheel connect the rotating thing connected to the motor, that is having a crank radius, and also the number of slots. This number of slots is very important in this mechanism, because based on the number of slots you can give a time delay for filling or manufacturing products based on the time that required for that packing or filling thing. So that is mainly assumed or calculated by the number of slots. As we increase the number of slots, we get we can vary the time for particular product in that point. Go back, sir. Go back, Sandeep. Calculation part. Go back. Not this one. Yeah. And next, the roller diameter, the smaller diameter which is connected to the motor, that is D, small d, and P is the constant velocity of a driving crank. That is the pin which is connected to the slot. No, that is a P. But that velocity will be considered as P in RPM. Okay, and the center distance B, it is nothing but the distance between the two centers. That is, one is of Geneva wheels, and the another one is the motor connected, the center of the motor, and I mean the crank connected center, that one. So that is the distance B, and D is the diameter of the Geneva wheel. So this is two things are very important in this calculation. One is the number of slots and the diameter. These two will determine the time delay that is required in the whole mechanism or the whole process of conveying the products from one point to another point, and the time delay required. So that is the main that can be calculated by these two things. One is N, and D, that is diameter. So these two are very important parameters in this calculations. Okay, then using the formula called D is equal to 2 into root of D square by 4 plus A square cot square 180 by N. So this formula, using this formula, we can calculate the number of slots or diameter. Okay, the diameter. So from this formula we can assume the dimensions or required dimensions can be calculated and manufactured. So this formula is very important for the time delay, and the dimension that is required for the time delay can be calculated using this formula. So this is very important formula. And also the angular velocity. So angular velocity is one more important, because when we have a dimensions proper, then the wheel the motor velocity, that the angular velocity should be constant. If it varies due to any reason, then the time delay may vary, and while manufacturing a large number of products, it may bring
Sanjay.
errors. So
Sanjay.
Yes, sir.
So instead of explaining all these calculations, no,
sir,
if you show the model and then explain the mechanism what you want to explain it, that is enough to know about this work. Because these calculations and all equations, everything, that is a regular procedure. No, you just come to the model and explain the model.
Yes, sir.
What actually you have done on this model.
Yes, sir. The whole process include that calculation itself, sir. Because if we are whatever we need the time delay or any in manufacturing process, if these dimensions are proper, then we'll get the required.
Okay, Sanjay. Remaining people have not contributed much, I suppose. Okay, except
No,
Sanjay.
sir. No, sir.
What did you do, Sandeep and Rakshit?
Hello, sir.
Ah.
Sir, I'm explaining the advantages and disadvantages of this process.
Explain that.
There are basically, sir, 4 types of conveyor system: roller conveyor system, powered roller conveyor system, overhead conveyor system, and belt conveyor system. In this project, we are using the belt conveyor system, sir. The advantages are, first of all, it's a cheapest process, and secondly, it's simple and easy to use, And the main advantages is we can use this process in bottle filling and capping. So in small scale industries, the bottle filling is done manually. It has a problem that spilling of water may takes place while filling the water, and equal quantity of water may not be filled, delayed due to the natural activities of the human. But by using this mechanism in the industries, the process will be smoother, and refilling can be reduce the manpower cost and operating time.
Okay.
The dis-
Okay. Enough. Next batch.
Sir, sir, we one thing to add, sir. Like we have
Yeah.
this is usual mechanism, but we actually plan to do it in a innovative way. That is, instead of using one Geneva wheel to one motor, as you can see
Okay.
here, we can use a single motor to use two Geneva wheels, so that we could cover a long distance of conveying products from one point to another point. So
Okay.
that was
Yeah.
our idea actually. Due to we can't due to such situation we couldn't.
Okay. Okay, Sanjay. Okay. Fine. Fine, Sanjay.
Thank you, sir.
Okay. Next batch. Chaitanya Vamshi, Nishant, Srivatsan, Madan Kumar.
Yes, sir. Yes, sir.
Will be marked absent here. Will be marked absent. 0 marks absent. Yes, yes, yes. Your whole team on helmet. Yes, sir. Yeah. Chaitanya Vamsi, Nishant M.
Yeah. Chaitanya, Nishant, Srivatsan.
Yes, sir.
Yes,
Yes, sir.
Chaitanya Vamshi is there. Srivatsan is there. Nishant M, he will not be there. Okay, definitely. Madan Kumar. Madan Kumar is also not there. Okay. Chaitanya and Srivatsa, what is that you have done? One of you present? Yeah, start Srivatsan.
Yes, sir. I'm starting.
Free energy generation by using flywheel. Okay, start. Have you done any physical model?
We have done roughly, so like it's like
yes,
a simple
sir, like
project.
not completely, but we have
Not complete. We have done.
Yeah. Do you have that model with you right
like we have
now?
not collected all components.
It's
We'll
okay.
play the
Do you
video.
have anything? Yeah.
Yeah, we'll play it, sir. Now we'll explain PPT.
Yeah.
We'll play it
Show
later.
the video. Show video or a product first. Show that.
Yes.
First we'll show PPT, sir. Then
No,
we'll
first show
show
the
how to
model.
play.
Video.
Then
Video or model you show me.
model, sir.
Then we go to presentation.
Okay, sir. Fine.
Good. Some
Sir, is it
physical
visible,
model
sir?
you have made. Will it work or just okay? Oh, fine. Very good. Okay, now we go ahead.
Yes, sir.
Actually, we have done it roughly, sir, because we're not getting the components actually.
Okay, fine, Srivachan. That's good
Yes,
enough.
sir. Yes.
That's good enough. Do it.
Yes.
Now go to presentation.
So our project is free energy generation by using flywheel. So myself Chaitanya
Okay, it's
Vamsi
okay. Next,
and
go to next slide.
okay.
This introduction is not required.
So basically it is a mechanical device which uses flywheel to store energy in the form of inertia. So
Okay.
in this we apply extra energy source to start the main motor like electricity or by applying the mechanical energy.
Okay.
The most interesting thing about this system is that great the that greater electrical energy can be drawn from the output generator than appears to be drawn from the input drive of the motor.
Okay. Go to the next
And
slide.
the inertia
Go to next slide.
contactless energy generation with flywheel.
Only important line you read. Don't keep reading the entire thing.
So uh, in- so in this generally we know that a significant amount of energy is actually wasted and transformed into heat. Instead of this, a prototype scavenging system to collect and reuse this energy is presented.
Next. Next slide.
So this is the flywheel.
Yeah, we are not getting the flywheel there. Go to next slide. Chaitanya.
Chaitanya, we are not able to see flywheel.
Okay, sir. Wait, sir. Yes, sir. This is the flywheel,
Yes,
sir.
yes. Explain now.
Explain.
So here in this, the inertia of the flywheel can be increased by increasing the radius of the flywheel and the weight of the flywheel. So so if the radius of the flywheel is more, inertia also will be more and
Yeah, go to
as
next slide. You are explaining the same thing again and again.
So here we are with the design objective of the project. So generally in physics we know that energy can neither be created or destroyed. It can only be transformed from one form to the other. But in this process, a lot of energy is wasted in the form of heat. So in this project we can reuse the energy without wasting it.
Next slide.
So these are the components which we use are flywheel, motor, neodymium magnets, coils, battery, and freewheel.
Okay, next. Explain the working. Next.
So
next.
So coming to the parts, the first part is flywheel. Engines are most efficient when they are producing power at a constant, relatively high speed. The only trouble is the vehicles and machines when
Hey,
they
you
drive.
cannot read text like this, I say. It is not a textbook reading session. It is a
Okay, sir.
presentation, PPT, only important point you should keep and explain. Okay, go to the next slide. Tell what is this neodymium magnets? Hello? Chaitanya Vamshi, are you there?
Sir. Yes, sir.
What, you went to sleep, huh?
No, sir.
Why have you used magnets in your work model?
Sir, actually, the magnets are not. I have searched, but the magnets are not. It's not available, sir. Like what components we got, we manage with that, sir.
Okay, right. But you intended to use magnets, huh?
Yeah, actually, if we use magnets, it will be better for us. Actually, it will be
Okay.
easier.
Okay, go to the next slide. Srivatsan, explain the remaining thing quickly.
So yes, the coil it produces design challenge. Actually, another challenge is that the small wire becomes it becomes less current, and wire begins to heat up due to increased resistance to small wire. Like each one of our coils has measured like 40 ohms and a small gauge wire, which and it reduces the resistance.
Next slide.
Next slide. A freewheel is a device that's used for transmission.
Yeah, Vatsan, explain the working of your model. That's all. Not explaining each and every part.
Okay, sir.
Finally, as assembly, explain.
Sir, in our model, we have connected to the DC motors and a plastic wheel, and we have used bearings and we use bearing as a flywheel, and we have connected and we have connected wires to DC motors. Once once we attach the battery to it, it starts rotating. It starts rotating, and after we remove the battery, it keeps on actually and it keeps on rotating. We can use it to generate bulb and fans.
Fine, Srivatsan. Okay,
Yes,
Srivatsan, good presentation. You have improved, I think, a bit more. Good. Okay, be bold like this only. Right?
Yes.
Okay then. Okay, Chaitanya, Vamshi. Prepare a bit more better way. Chaitanya. Right.
Actually, we searched on getting parts. Actually, sir.
No problem, Srivatsan. We can understand. Okay.
Yes, sir.
Yeah. Next batch. Vijay Kumar.
Yes, sir. Yes, sir. Yes, sir. Good afternoon, sir.
Only Vijay could be there.
Sir, only me I am having, sir. Another so they did not come.
Shadab will not come. Suman Xavier will not come. Zahir Hussain is not. Yeah.
Okay, fine. Go on,
Sir,
Vijay.
I will present in my mobile, sir, because it's not opening in my laptop, sir.
Okay, no problem. Carry on.
So my screen is visible, sir.
Vijay Kumar,
Sir,
have
yes,
you
sir.
done physical model of this?
Sir, no one is there with me, sir. I am still I am getting almost 30% I have done, sir. Still 60% I have to do it done, sir.
Physical model.
Yes, sir.
Have you taken photo of the physical model here?
I have schematic diagram, block diagram, sir, in the PPT.
No. I am asking you physical model, whatever that you have done, is it now there or not?
No, sir. I have ordered few parts, sir. Still 1 week I have to get that parts, sir.
Physical model. Yeah. Go ahead with your presentation.
My PPT is visible, sir.
Yeah.
Okay, sir. Myself, Vijay Kumar. Today I'm going to present the design and fabric of mini hydraulic jack under guidance of Sri Ganesh TG, sir. I explain few briefly about abstraction of mini hydraulic jack. Here we study about fabrication of mini hydraulic jack uses power of operation jack in vertical movement, sir. Mini hydraulic system consists to design hydraulic jack that is capable of lifting relatively high weights as compared to its sizes. Lifting of jack mechanism made lightweight but strong materials. It can be handled easily to change locations in we required locations. This mechanism is powered by the spring in the way of to achieve the most weights lifting mechanism as compared to the sizes. The system consists of bed mounted on top of the mechanism where the car or weight to be lifted is to be placed. 1 minute, sir. Sir, my PPT is visible.
Yeah, it's visible.
Okay, this is the block diagram of my project. The main components we are using here is a lifting frame, bed and supporting frame, joints and screws, screws of fasteners, spring, syringe and pipes. The project development stages is finalizing the mechanism and project design, parts procurement, parts fabrication, project assembly testing, and finalizing the mechanisms step by step. Make a list of required hardware outputs. Examine the mechanism architecture. Select the architecture. Identify motion needs. Starts. This is not examine cost and power constraints. Check the parts availability. Calculate the sizes. Fabrication parts. The project design is mechanical design or machine design is one of the important branch of engineering design. To understand what exactly machine design or mechanical design is, let us the example of a gearbox of the car. So
Vijay Kumar, go to your work. What you intended.
This is a project design, sir. This is not required. I
No,
think
don't
so.
worry about project design. Go to your work.
The main fabrication, I will explain this parts fabrication. Sir.
No. You go to your hydraulic, what is that? Hydraulic jack. Whatever the fabrication or design that you have done, you show me.
Okay, sir. 1 minute. The fabrication parts.
No. All these things don't show. These are all general. We go to your work. Go to your work. No,
Okay.
all these things are not
All this
required.
you not required, sir.
Not required.
Okay, sir.
Go to whatever that you have done.
This I will explain, sir. Schematic diagram. This is a schematic diagram.
This is Pascal's law. Okay. Next.
I will explain this, sir, by showing this
No,
video.
not required. Next. Go to next.
Okay. This is the last serum that I will explain. What you need to explain, sir? Tell me, sir. I will explain. Sir.
Just explain the above slide. The Pascal's law. Yeah.
Pascal's law, sir.
Okay,
sir. The Pascal's law states that the pressure applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid to the walls of container. The pressure at any point in the fluid is equal in all the directions, sir.
Okay. Hello. So this is the concept of hydraulic jack. Okay.
Yes, sir. If you need, I will explain this schematic diagram. Unless I will explain, tell the advantage and disadvantage of that.
No advantage. You just explain this
schematic diagram, sir. From right side of the document, we will show the force. Force will apply smaller force. We will apply first, sir. The piston moves towards the fluid. Piston move towards the fluid, sir. The fluid will incompressible, and the fluid goes to the where we need to require the lift of jack, sir. The force will be greater at the lift of jack, sir. We will first starting the man will apply the force smaller force, and where we need to lift the jack, the force will be greater. At the required position, the jack will be raising the piston, sir, at required height, sir. And the advantage of this mini hydraulic jack is in a compression to be normal jack in comparison to a normal jack and hydraulic jack are able to lift heavier loads easily at greater heights by applying a small amount of force. Disadvantage of this mini hydraulic jack is it is susceptible for the failure if oil seal are worn out. This can be cause serious problems. It has a relatively slow speed. Hydraulic oil can emit unpleasant odor when became too warm due to the overuse. It can overheat fairly quick. The hydraulic oil leaks can cause soil and water pollution.
Vijay Kumar, can you know what are the liquids you use in this hydraulic system? Incompressible liquids?
We can use any of liquid, I think so, sir. I don't particular idea.
Okay. Water can be used, huh?
No, sir. Water has no. We can't use water, sir.
Why?
There is a otherness. I think water is not otherness, sir, in water.
Okay. Okay, Vijay Kumar.
Okay, sir. Thank you, sir.
Right. Okay. Ready? I think you can stop recording.
Yeah, Srivatsan, can you leave the this one?
Yeah,
Google.
one second. Srivatsa.
Yes, sir.
You
Yes.
have that model, no? You just present it once. I'll take a photograph.
1 minute, sir.
You have that running model, no?
Yes, sir.
Just present it. I forgot to take photograph of it.
Vijay Kumar, you can leave the.
Hey, Reddy, you can stop recording. Reddy.
Yes, sir. Yes.
Stop recording.
Okay.